But look at this. All right, can you see that? Look at that. This is why this board is... It's a new day and we have another phone that needs to be fixed. Today we have an iPhone 12 Pro Max that has no power. Our note just says dead on arrival and we have no further information. So first let's just try to turn this thing on and see what happens. We're at battery voltage, there's no short. Pressing the power button. And we're getting a quick spike up to 100 milliamps. It's so quick that it doesn't even pick up half the time on my multimeter display, but on my power supply I can see that when I click the power button, it jumps up to 100 milliamps and then instantly drops back down. So usually this type of response is caused by a NAND short. We're gonna use the thermal camera and see if anything glows up near the NAND. So when we're scanning, we're paying attention to this area. These capacitors near the NAND could be short and we're hoping to see one of them glow up when we're pressing the power button. And we're not seeing anything. So let's scrape all the glue off of these capacitors and then check again. And you can see that some of these are hidden in a mountain of glue. So that's why we wouldn't be able to see them without removing the glue first. Okay, our board is cooled off. Let's check again. I'm not seeing anything on the top, so let's measure all our NAND power rails and see if anything is short. And it looks like we have a short on PP2V625 NAND. Let's check with diode mode to see what exactly we get. And we get full 0. Wow, lucky us. The first line we measure is short. So now we can inject voltage and keep it on so that it's more obvious where the heat's coming from. Because with this millisecond long blinking, it's really hard to see any sort of heat. We just have to make sure that we don't inject more than 2.5 volts. Okay, we've tacked on our jumper. Let's set this to 1 volt to start. And let's see if we get any current draw. And yes, we do. 1.5 amps. Let's actually turn this down a bit because we don't need that much heat. Okay. Now we're drawing 1 amp. This short should be very visible now. And right there we can see our short capacitor. Right there. Right over here, this is our bad capacitor, or so we think. Remove the jumper. And remove the capacitor. Is this capacitor short? What do you think? Yes, it is short. How surprising. Is our NAND power rail still short? No, it is not. We're getting 0.35. Let's test our boot up again. Let's see our power up response. Turning up voltage, 3.8, power button, and it looks like we are still getting a short. But this time it's a different line, I guess. Let's measure the rest of our power rails. And look at that. The second rail we measure is also short. Let's verify with diode mode. We're getting full short 003. This line is PP1V2 IO. So let's do the same thing. Let's put our jumper onto this line and then scan it with the thermal camera. We have our jumper tacked on. And we're getting current draw. So at half a volt, we're getting half an amp. So let's check with our thermal camera. And this time it's not so obvious. Let's turn up our voltage a little more. And when we burn it, we still don't see it. So unfortunately, it looks like our short is on the inside. So if we check our schematic drawing, we have capacitors on this 1V2 line inside this shield and also inside the board. So what I want to do first is remove this shield, and if we can't find it still, we're gonna have to open the board up. Oh, look at that. Our shield is bent. Can you see that? So I'm very confident that there is a short under here. You can even see, you know, an indent of some of the components beneath it. So it's very possible that one of our components has cracked. And taking a look, none of the ICs seem to be cracked. We did lose this capacitor while removing the shield. This is a VDD main capacitor, so we have like a zillion of them. Let's just take this off. And let's inject one more time. I'm gonna inject in a different spot this time, just in case that capacitor we were injecting on just happened to be the short, but I doubt it. But it's always good to rule these things out. All right, we've tacked our jumper on. We have 0.8 volts loaded up. Let's see if we find anything. Oh, that is not good. Okay, not only do we not see any capacitors lighting up, but I see the board underneath these components glowing a little bit. It's very hard to see. I'm actually going to turn up our voltage to, let's see, what can this line handle? 1.2? Okay. We're gonna inject 1.2. And let's see if we can get a little bit stronger heat. Yeah. And you can see that heat just glowing underneath this area. And the bad news is right on the other side of this area right here specifically is the CPU. So we have no choice but to separate the board. And I'm just praying that our CPU is not short. Oh boy. Oh boy. So it looks like this board suffered from very heavy impact. As you can see, when I removed the layers, this coil just popped off, like it wasn't even attached, which is not a good sign. Very not good. And then you can also see basically every single pad on the layers is ripped off. Just a fucking disaster, honestly. So if we do want to fully fix this device, it's going to require a lot of pad repair. But before I even go that far, I'm going to make sure that we can get rid of this short first. Because if our CPU is dead, then there's no point continuing to jumper. We try to reball the CPU, and then if that doesn't work, it's over. But let's see where this heat is coming from first. Oh yeah, that's really not good. Can you see it? Our CPU is short. Not good, guys. Really not good. So yeah, there's no denying it. The only heat is coming from our CPU. So let's think for a second. There's two possibilities. One, our CPU is still fine and it just needs to be reballed. Or two, our CPU is dead and we'll find out once we test this on another board. Since our upper board is already missing so many pads, and we also don't know that all of the other components work, I don't think reballing this is a good idea. It'll just be a waste of time. So I'm just going to directly transplant our CPU, NAND, and EEPROM to a known good upper board just to verify the state of the CPU. Okay, my friends, this is what a board is supposed to look like when you separate it. All the pads are there. Let's do a quick comparison. Look at the difference. Jesus. All right, let's remove our original NAND. Luckily, our NAND does not have any ripped pads. But I have a bad feeling about the CPU. It might be a fucking disaster underneath. I'm scared. I'm curious to see once we remove the CPU if our NAND short will be gone, which it probably will be. We want to fully melt this to ensure that none of our pads rip. Watching this footage back, I can't believe I didn't see the issue with the board. Maybe you can tell what it is, but if not, you're about to find out soon enough. Okay, CPU is off, and first glance it doesn't look too bad actually. I'm actually impressed. I don't see a single ripped pad. So the entire interposer got completely fucked up, but somehow the CPU is completely intact. Okay, now what I'm really curious about is if our NAND line is now no longer short. And yeah, our reading is 0.3 now. So the CPU was causing the short. So hopefully that doesn't mean our CPU is dead, which it might be. Hopefully it just needed to be reballed, but we're about to find out once we install it onto the new board. Okay, I was a little too forceful with that removal, but I wanted to make sure I didn't overheat the board itself. Let's clean this up. Okay, NAND is removed. Let's remove the CPU now. And let's really make sure not to overheat this because our power IC is right here and I'd like to avoid having to reball it. I would honestly rather rip the pads of this CPU than to overheat anything. So we're gonna remove from the top here. Looks like we're a little bit overheated. But I don't see any solder squeezing out of here, so our power IC should be fine. All right, let's install the CPU. Installation looks good. Before we do the NAND, I'd like to make sure this can go into DFU mode. Uh-oh. We're getting the same response as on the old board, so that's really bad news. We might have a dead CPU, guys. Let's measure our short line. Uh-oh. Guys, it's over. This is a no fix. Okay, so I was removing the CPU from the donor board so I could keep it in stock for next time, and I actually noticed what the problem was all along. I sort of saw this a little bit when I was installing the CPU, but I didn't think much of it. But look at this. This is why this board is not recoverable. You see this scratch right here? Well, it's not a scratch. I'm gonna put on my 2x Barlow lens and let's see if we can show this. All right, can you see that? Yep. Our CPU is cracked. Cracked in half. That is unfortunate. Look at that. Look at that. You can even see it on this edge right here if you look closely. So yeah, that's the end of my streak. We finally failed on a repair. Now we know that that power response is a symptom of the CPU being cracked in half. Good stuff, guys. We're learning. Yeah, not much else to say. I'll see you guys in the next video.